Quadratic functions allow you to get a small glimpse at a calculus type application, which is called optimization. When you optimize a function, you're looking for the maximums or minimums of the functions, and that can have some good practical use to it, as we'll see later on in this section. Anyway, a quadratic function, y or f of x, would have the form of ax squared plus bx plus c. Now that probably looks familiar to you. You've been through quadratic equations and have learned the quadratic formula. And here it is written as a function. Well, these quadratic functions, as we find out, are parabolas. It might go like this, which is a right side up parabola, or it could go upside down, for example. And there are only two choices for a true function for parabolas. They're either upward pointing or downward pointing. One thing we want to take advantage of with quadratic functions is that they each have line symmetry. There's a vertical line which crosses through the vertex. So let me label this. This is the vertex of the parabola. And this line here has a name. It's called the axis of symmetry. And the axis of symmetry is the line of symmetry for a parabola. And they all have it. So this one has this axis of symmetry, and there's the vertex. Okay. Now, you might think, well, what would tell us by looking at a function which type this is? Because that's important to know. Because here, this vertex is the minimum of the function, and that vertex is the maximum of this quadratic function. And so what tells us this is the leading coefficient, a. And if it's positive, then it's going to be pointed upward. And if it's negative, then it's been reflected along the way. It's been reflected around the x-axis, and now the parabola points downward. So we can make this sort of blanket statement here. If a is positive, then f of x has a minimum. Okay, and the minimum is at the vertex. And also if a is less than 0, then the function f of x has a maximum. So it sort of works opposite there. Negative leading coefficient means you have the maximum. Now, it's important to realize this only applies to parabolas. Okay, don't generalize that to all functions. That's just not going to work in general. But well, for parabolas. All right. So the question becomes, how do we find the vertex? You know, if we're interested in knowing where the minimum or the maximum is, then where in the world is the vertex? How do we determine that? Your textbook has a method using completing the square in order to find the vertex. And what they're doing is it's a technique by which you take the function and you massage it in a certain way so that it fits a format. And so, for example, if you're let me do a little erasing here. Here's what I mean. If you can rewrite your quadratic function so that it has this form, y equals to a, parentheses, x minus h, quantity to the second power, plus k, written in that form, then the point h comma k is the vertex of the parabola. Well, and it's a nice technique. This completing the square is a nice technique to learn. I have a simpler technique I want to show you as an alternative, and it goes quite a bit faster than this completing the square technique. But I want to develop it. I just don't want to give you a formula. I think it's not real learning if you just hand someone a formula. So I want you to sit through the derivation of this technique. So here's what I'm going to do, because it really does take some work to go from here to here. And this, by the way, this kind of might remind you of the equation of a circle, where HK was the center of the circle, but here it's a different format. All right, so here's what I want to look at. If suppose my function looked like this, and so it comes down, goes back up, and it's the way I've written this one. It crosses the x-axis in two places, here and here. Now we're going to call those the roots of the equation, and later on they're the roots, they're the x-intercepts. But it's what happens when you set your function equal to 0 and solve. Because when this function equals to 0, it's the same as when y equals 0. And this x-axis is where y equals 0. And so solving this equation gives you the two roots of the equation. Now, and how do you solve that equation? Well, the quadratic formula gives us a solution. So there are two answers. And suppose that this answer, when you solve that equation, is x equals to minus b plus the square root, b squared minus 4ac, all divided by 2a. And I meant to make this a minus here. So sorry about that. And then this root would be x equals to minus b plus the square root, b squared minus 4ac over 2a. So recall from the quadratic formula, when you solve it, you get minus b plus or minus the square root, all over 2a. And so that plus or minus, means there are two separate answers. And why don't we call this the negative and this the positive, for the answers here. All right, now where is the vertex? And it's right in the middle, isn't it? If I draw this axis of symmetry, it crosses right through the middle and bottoms out at the vertex. So, what we're doing is we're taking advantage of the symmetric nature of the parabola or the quadratic function. And it's really nice because, how do you find the middle of two numbers? You take the average. The average is the middle of two numbers. And so you take average by adding two numbers together and dividing by 2. Now if I added this term and this term together, and I've done this in my book, if you add these terms together, it looks bad, but it doesn't, because the square roots will disappear. Here's the negative square root, and that will cancel with a positive square root. So if I add those together, I get minus b over 2a, and another minus b over 2a. If I divide that by 2, then I get 1 minus b over 2a. So all that's shown in my book. And basically I've kind of waved my hands here and said that the x coordinate would be minus b over 2a. And so the x coordinate of the vertex is literally the quadratic formula without the square root part. And you think about that, you say, well, what are the roots of this equation? It's x equals minus b over 2a plus or minus some other stuff. So here I am in the middle. If I plus that quantity, I get to here. If I subtract it, I get to there. And so it has to be in the middle. All right, so here's a nice little formula which we developed. And that's going to tell us exactly where the x-coordinate is of the vertex. And then how would we find the rest of the vertex, the y-coordinate? Well, then, once you know x, plug it into the function, and you calculate y. So I'm going to erase the board and give you an example of applying this to find the vertex of the function.